Okay, on to our next set of problems. This is where we're looking at exponential functions, and then we'll start looking at log functions. So exponential functions is when we have a variable that's in the exponent. So anything where you see there's a variable in an exponent, you can start to approach them possibly through these methods. So the first thing we want to do is graph a function that looks like this, be able to identify the horizontal asymptote quickly and easily, and state a domain and range from this. So this gives us a pretty quick, at least, idea that we have a horizontal asymptote, so that should start off making things a little bit easier for us. So let's think about what are some possible, some possible values for x and y. Well, again, I like to see what happens with some numbers that are positive and 0. And then when we plug into the base function, we are thinking about y equals 2 to the x power, okay? Because that is the base of our function. So we have 2 to the 0, 2 to the 1, and 2 squared for the parent function. And those coordinates are 2 to the 0 power. Anything to the 0 power is 1. 2 to the first power is 2. And to the second power is 4. Okay? So now I can clean this up a little bit and start to apply my different transformations. First transformation I see is I've got this a value over here. So a is equal to 3. That tells me there's a vertical stretch by 3. So I'm going to be multiplying by 3. 1 times 3 is 3, 2 times 3 is 6, and 4 times 3 is 12. Next, I'm going to see that I have this h value. H is negative 1. Now, anytime that I have a negative 1, I'm actually going to be adding 1 to all of my x values. So that's 1, 2, and 3. And then finally, we have the k value, a k of positive 2. So when k is positive 2, then that means we're going to be adding 2 to each of those values, and that gives us 5, 8, and 14. So there are my points that I'm going to plot. I'm going to have the point 1, 5, which is going to be up here. And we're going to have a point 2, 8, which is going to be right here. And then we are finally going to have the point 3, 14, which is going to be right up here. And this starts to look like almost a straight line, but not quite, so I don't really see too much. So what happens if I have negative 1? Well, 2 to the negative 1 power is going to end up being 1/2. It's the reciprocal of that. And then I multiply that by 3, and then I add 2 to it, and I end up with 3 over 2 plus 2, and it ends up being really gross. So that ends up being really hard to try and find this. I don't want to have to mess with all this. What I want to remember is how can I find the horizontal asymptote? And the horizontal asymptote is actually found by this number k. So k is always going to be the location of your horizontal asymptote. And remember, that's a vertical line or a horizontal line that the graph is never going to be able to touch. So we draw that horizontal line here at positive 2, and we just know that this curve is going to be a smooth curve. It's going to approach it but never actually touch it. And then that tells me exactly what the pattern should look like. And there's my exponential growth function with that horizontal asymptote being x equaling 2. So we can write that out. Horizontal asymptote is that x equals 2. Then we can, not x equals 2, it's going to be y equals 2. And then we look at our domain and range, and we say, okay, well, this graph is going forever to the left and forever to the right, so that means that x is going to be equal to all real numbers. But then we have for the range that horizontal asymptote limits us. We are bound by that horizontal asymptote. Now we're always above that value of y equals 2. So we can say for our range is that it's going to be all y values that are going to be greater than, not equal to, but just strictly greater than 2. So there's our horizontal asymptote and our domain and range as well as the graph. Done and done. Next thing we want to do is try and solve an exponential equation. So what we want to try and do here is get the same base on both sides. Here my base is 5, but then my base is 125 on the other side. What I want to try and do, remember, we want to try and get the same base. So I can remember that 5 to the third power is going to equal 125. So the right-hand side, 125, is the same thing as 5 to the third. We set the left-hand side equal to 5 to the 4x plus 1. And then what can we do at this point? We can just say, hey, when my base is the same, the only thing I need to do is worry about the exponents. So that becomes this equation, 4x plus 1 equals 3. And now I can do some simple algebra. We turn this algebra 2 problem into an algebra 1 problem, and we can do some real easy stuff here. 4x will equal 2, and then we can undo that multiplication by division, and we sure enough have x equaling 2, 1 over 2, and that is our solution. Okay, so that is going to help you out with problems 18 and 19. Try those out for size.